All right, so let's work on the first question where we're asked to find the quotient and the remainder. So let's copy the question 1a. So 1a says that we have a is equal to 25 and b is equal to 73. So we're going to use the following idea where we have that a is going to be equal to the quotient times b plus the remainder. So in our case, for 1a, we have that 25 is equal to the quotient times 73 plus the remainder. Okay, so we then try to find out how many times does b go into 25, and we see that it goes 0 times. So we can then substitute that we have 0 times 73 plus some remainder will equal to 25. So this is 0. So you would need a remainder of 25 for the equation to be true. So this gives you the result that the quotient is 0 and that the remainder is 25. All right, let's move on to 2b, or actually 1b. So for 1b, we have that a is equal to 73 and b is equal to 25. So we're following the idea that a is equal to some quotient multiplied by b plus some remainder. If we plug in the values, we get that 73 is equal to the quotient times 25 plus some remainder. All right, so we can now find out how many times 25 goes into 73, and it goes at least twice. So it goes in twice. Right? 2 times 25 is 50. If we choose 3 times 25, it would be 75 would be bigger than 73. So we have that 2 times 25, that gives you 50, and we would have how much further to get to 73? We would need 23 more to get to 73. Right? Then we have that, plug it in again, it comes out to be that 73 is equal to 2 times 25 plus 23, and from this we have that the quotient is 2 and that the remainder is 23. All right, now let's move on to 1c. So for 1c, we have a is equal to minus 17, and we have that b is equal to 79. So again, we're following the idea that a is equal to some quotient multiplied by b plus some remainder. If we plug in the values, we have that minus 17 is equal to quotient times 79 plus some remainder. So we need to know how many times 79 goes into minus 17. Well, one way to think about it is that if you have all the numbers here, integers, where you have minus 17 here, we have a 0 somewhere around here, and then we have 79, right? We need to know how many times does 79 goes into minus 17. So if these were whole numbers, the question would be, say you have the number 2 here, and you're asking how many times would 2, this distance, go into that total distance? Well, then it would fit multiple times, a number total of 5 times. So the same question can be asked here. How many times does 79 go into that total distance, which is 96? So 79 goes into 96 one time. But because it's negative, then it's minus 1. So we have that 79 goes into minus 17 minus 1 time. So we have that minus 1 times 79, that's minus 79. And to reach minus 17, we would need to add 17. That would give you 62. So we have that the quotient is minus 1 and that the remainder is 62. All right, now let's take a look at 1D. So for 1D, we have that A is equal to minus 73 and B is equal to 25. All right, so we have that A is equal to the quotient times B plus some remainder. If you plug in the values, we have that minus 73 is equal to the quotient times 25 plus some remainder. So the question here is, how many times does 25 go into minus 73? So again, so we go through the same idea. We have a minus 73 here. Somewhere here we have 0, and somewhere here we have 25. So we're asking, how many times does 25 go into minus 73? But really, we want to know how many times does 25 go into the total distance. And that distance is 73 plus 25, and that's 98. So 25 goes into 98 3 times. So if we plug in the values, we get minus 73 is equal to minus 3 times 25 plus some remainder. So minus 3 times 25, that's minus 75. So how much more do I need in the remainder to get to 73? So that would be that I would need the remainder to be 2. So this yields that the quotient is minus 3 and that the remainder is